Alright guys, so in this video we'll be going through how to plot the cumulative density function for continuous data. So we have a piecewise function defined by 1/3 between 0 and 1 and 2/3 between 1 and 2. So before we get to the CDF, if we were to plot the PDF, which is the probability density function, so between 0, 1, then 1 to 2. So the set between 0 and 1 is 1/3. So that would just be up here. And then between 1 and 3 is 2/3. And 0 otherwise. All right, so this will be how the PDF will look, or the probability density function. Right? To get the CDF, you have to remember that this CDF, which is capital F of X, is basically the probability of X being less than or equal to some value X. Right? You have to remember that. So what we need to do and we have to remember is capital F of X. In this case, the probability, remember, is the area underneath the graph for continuous is equal to the integral from minus infinity to whatever ending of f of x dx. So when you integrate the PDF, you get a CDF, right? So that is something important. So we just integrating the PDF, each piecewise function to get the CDF. So there's the trick to do it. So the first thing you need to do is you need to just write a number line with the numbers or the boundaries in which they gave you. So in this case, I'll just draw a line as straight as I can. So we know we started from minus infinity. All right. So then the other points, well, the first one is 0, but I where it started. So 0 to 1. So 0 to 1, and then from 1 to 2. And all we do is writing the function that they gave us for that boundary. So between 0 and 1 is 1/3. All right, and between 1 and 2 is 2/3. So this would be like a sketch of the PDF, right, on a number line. So between 0 and 1 is a third, and between 1 and 2 is 2/3 in this case. So we'll write whatever function they had given between the two. All right, and they said 0 otherwise, so 0 or 0. Okay, so what we need to do, we know that capital alphabet, which is the CDF, is the integral of the PDF with respect to x, right? So our CDF graph will still look like the PDF in terms of the x and y axis in between the bounds, so 0, 1 to 2. But what we need to do, we need to integrate the PDF cumulatively, right? So what I mean by that is, so for the first interval from 0 to 1, the function is 1/2, right? So since it has nothing before, it is going from minus infinity, and the capital F is the probability of x being less than or equal to. So in this case, that's how it does do it. So between 0 and 1, it could just plot arbitrary x here. Once it's in between these two bounds, remember it had to start from here. In this case, the function itself started from 0. So that's where you started, right? So in this case, the probability of x being less than or equal to x will be 0, and then you have 1 to in between. So how it will look, I'll write it. So it'll basically the integral from minus infinity to 0 of 0 dx, right, plus the integral from 0 to x, right, some arbitrary point in between the first one. And this case will be a third dx. Yeah, and then For the other interval, I won't do the integration as yet. From 1 to 2. So I'll use a different color. So if it's 1 to 2, that means it's somewhere in between here. So remember, we have to cumulatively add up the area. So it'll be the integral of this piece plus the integral of this piece plus the piece of integral in between here. X will be any point in between 1 and 2. Right? So that's how you could think about it. Right? You have to cumulatively add up each piece before. So between this one, it'll be the integral from minus infinity to 0, which we know is 0, plus the integral from 0 to 1 over 2, and plus the piece that we in now. So it'll be 1 to arbitrary point x, or 2 to dx. And this is where it will cumulatively adding up the probabilities. In this case, you have to integrate. All right? So now let's do the integration for the first piece. So the integral of 0 is 0. And the integral of a 2, right, so it will be, so when you add the x, it will be 1x on 3 between the bounds of 0 and x, right? So obviously we'll just end up as x on 3, right? So that's the first piece, all right? Then for the second piece now, so the integral of 0 is 0. The integral of this here will be x on 3 between 1 and 0, plus this way will be 2x on 3 between 1 and x. So it'll be 0 plus, when you plug 1 into this, you'll get a third. So it just stay as a third, because when you plug 0, you get 0. And this will be plus 2x on 3 and minus 2 on 3. There's always the top plug it in minus the bottom when you plug it in. All right, so I'm putting it all together. There'll be 0 plus 1 third plus 2x on 3 minus 2 on 3. Bringing it together now, you have 2x on 3 and a third minus 2 to be minus 1 to. Right, so you call that one y2 and you can call this one here y1. Right? So now these are the two lines or the two graphs that you'll have to plot in between the bounds for the CDF. Right? So when you integrate the PDF, you'll get two different line graphs, right? So between 0 and 1, we had x on 3. So x on 3 means the y-intercept is 0. All right, and it going up to x. So the graph itself is x on 3. So if I plot in x on 3, y-intercept is 0, which you know that. And then we need to know where it ended. So plus plug 1 into it, because the maximum will go up to. So it does go up to 2. All right, so if we plug a 2 here, so just go up to 2. Straight line. All right, so that's the first piece. So the second piece was 2x on 3 minus a 2. Yeah, let's make it sure. Right. So that's starting from here and continuing for the second piece. So the y-intercept is minus 1 on 3. So that is down here. All right. And then positive gradient, so we'll kind of go up like this. All right. So same as before, we need to know where it will end. So you just plug 2 into this. So you'll get 4 on 3 minus 1 on 3. You get 3 on 3, which will give you 1. All right. And then it will just be 1. forever and ever and ever. Okay, not gonna change. All right, and that there will be a CDF. So that's a recap. You have CDF, so you have a PDF here, they'll give you the PDF here. Right? So remember, to get the CDF, you have to integrate the PDF cumulatively. And remember, why are we integrating it? Because for continuous, the integral of the graph will give you the probability. Right? It's still probability. So you integrate the PDF to get the CDF, but you have to do it cumulatively, which means you have to add up the areas before it. Right? So what we did, we drew up a line so we could see what the graph will be in between each bound, so between 0 and 1 and 1 and 2, which what they gave us. So between 0 and 1 it was a third, and between 1 and 2 it was 2/3. So the first piece obviously was up to 0, which we know will be 0, right? And then the first real integration piece will be from 0 to 1. So it'll be the area before, which you know is 0, plus the area in between. It could be any point in between, all right? So it'll just be 0 plus the integral from 0 to x of 1 to dx, and you integrate that and you get a piece. Then for the second piece, it will be from 1 to 2. So you have to cumulatively add the area before it and in between it. So it'll be 0 plus the integral of the 1 to between 0 and 1. And then it'll be plus the integral from 1 to x, or 2/3. All right, so let's do that and you'll get the two lines like we did down here. So 0 to 1 before 0 and between 0 and 1. You have this piece here. And then from 1 to 2 it'll be 0 plus the 1/3 from the area before and plus the in between. And I get the two graphs. And after that, you just plot it. Simple. The end like that. And that'll be the CDF for continuous data. All right, so we'll continue in the next one and we see.